Question 3a. We're asked to find, in terms of p, the remainder when x cubed minus 2x squared plus px minus 6 is divided by x plus 2. So clearly we need to do polynomial division. So we're taking x goes into x cubed, x squared times x is x cubed, x squared times 2 is 2x squared. We then subtract this. So x cubed minus x cubed is 0, minus 2x squared minus another 2x squared is 4x squared, but it's negative, plus px minus 6. X goes into negative 4x squared, negative 4x times. Negative 4x times x is negative 4x squared. Negative 4x times 2 is negative 8x. And we subtract this. And we're left with negative 4x squared minus negative 4x squared disappears. Px minus 8x gives us px plus 8x minus 6. Now clearly px plus 8x can be rewritten as p plus 8 outside of x. And then we can carry on, so x goes into p plus 8x, p plus 8 times. P plus 8 times this is p plus 8x. P plus 8 times 2 is 2 outside of p plus 8, or 2p plus 16, which we then subtract. So we have p plus 8x minus p plus 8x disappears. Negative 6 minus 2p minus 16 gives me minus 2p minus 22. And that is the remainder. In this question we've been asked to find the value of p for which x cubed minus 2x squared plus px minus 6 is exactly divisible by x minus 3. So like the previous question, we need to do polynomial division. So we have x cubed minus 2x squared plus px minus 6 being divided by x minus 3. So x goes into x cubed, x squared times x is x cubed, x squared times minus 3 is minus 3x squared, and we do a subtraction that results in x cubed minus x cubed disappears, minus 2x squared minus 3x squared becomes minus 2x squared plus 3x squared, which is just x squared, plus px minus 6. So x goes into x squared, x times x is x squared, x times negative 3 is negative 3x. We're going to subtract this and we are left with x squared minus x squared is clearly 0. Px minus 3x is p plus 3x. Bring down the minus 6. So then p plus 3x divided by x is p plus 3, which gives us p plus 3x. P plus 3 times negative 3 is negative 3 outside of p plus 3. We subtract this. P plus 3x minus p plus 3x is going to disappear. Minus 6 minus 3 times p plus 3 becomes minus 6 plus 3p plus 9. So this is clearly 3p plus 3. Now, the original condition we're told is that x minus 3 evenly divides this expression, which means the remainder should be 0. So clearly, if we take 3 to the other side and divide by 3, we're going to have that p is equal to minus 1. And that is the answer we're looking for. In this question, we've been given the quadratic with the rule y is equal to 2x squared plus mx plus 8. And we've been asked to find the values of m such that there is one solution or two solutions. So clearly what this is about finding the discriminant so that discriminant here would equal 0 and discriminant here is positive. So what is the discriminant? Well, it's b squared minus 4ac. So in our case, that is m squared minus 4 times 2, which is 8, times 8, which is 64. So we want to know what values of m will make this 0 and what values of m will make it positive. So first let's look at m squared minus 64 equals 0. Therefore m squared is equal to 64. Therefore m is equal to plus or minus 8. So there are in fact two values of m which would make this equation have one solution. If we look at then what does this in fact mean in terms of making sure it's positive? Well, anytime you look at the discriminant and you're asked to find where it's positive or negative, the first thing you should be thinking about doing is graphing what the discriminant looks like. This is clearly a quadratic. It's a happy face quadratic. And being a happy face quadratic, that means it's going to look like this. We know that it's vertically shifted down 64 units. There's no horizontal shift at all. So it will have a y-intercept of negative 64. And it will have two x-intercepts, which we've just found in the previous question, of 8 and minus 8. So clearly, when we look at this, at 8 and minus 8, it equals 0. Okay, remembering that this is a graph of the discriminant. Between negative 8 and 8, the discriminant is negative. So, when m is an element of negative 8 to 8, discriminant is negative. And that refers to, obviously, this area of the graph. Out here, clearly, the discriminant is positive. And out here, clearly the discriminant is positive. So that tells me that when m is an element of negative infinity to minus 8, non-inclusive, union 8 to positive infinity, that the discriminant is positive. And that is the solution to part B.